padding and the length feed are added to a message, each block of message consists of 64-bit words. Now see, here all of you know that the block in this particular block, it is a what? It consists of 1024 bits. Here it consists of 1024 bits, right? Basically, it is a what? Multiple of 1024 bits. Now read here. So what I'm trying to say, basically, see here the initial digest is mixed with what? It mixed with this the first block, right? So basically here these are word these you can say that it's a word oriented, right? So the SHA-512 operates on a word. It's a word oriented, and the word is defined as a 64 bits. Means that after padding and length feed are added to a message, each block of the message that consists of a 64-bit word. Now, all of you know that what is padding and length feed, right? So, and the message digest is also made of 64 bits. So now see, I'm talking about the one particular block, everyone. So here 1024 bits means I can say that total how many words? Total 16 words are there and each of 64 bit. And that's why it is what 1024 bits. Now see, in this figure you have to assume that the first particular block means how many words are there? Total 16 word and each word of 64 bits, that is equals to 1024, right? So this is I'm talking about the block number 1. Again I can say that the block number 2, total 16 words, each of 64 bits, then you are getting 1024. Up to this clear, everyone? And in this message digest, it's a 512 bits, right? So here I can say that total 8 words and each of 64 bits. So what I'm getting 512 bits. Up to this clear, everyone? Is it clear to you all what I'm trying to say? Hello, can you hear me? Hello. Okay, so I think all are clear up to this, right? So now this all about this word, right? So all of you know that this is the initial value, and what is this value? So basically now all of you know that the block 1, that means total 16 word and each of 64 bits, that is equals to 1024 bits. Okay, so now the another question here is your mind, that is what is this compression function, right? What is this compression function? And after that, how I am getting this 512 bits? So in this initial structure, I told you that this initial message digest is there. It is mixed with this block 1 of the message. Then here some processing are done, and finally what I am getting 512 bits means first intermediate digest that I am getting. Now how we are adding this first intermediate digest? So for that, first you have to understand this compression function, right? So now what is this compression function? Now for that, see in this properly it's visible. So I will show you this figure so you can understand. Now see here in this case, what happened? So see the first figure, that is A, B, C, D, E, F, G, H. Now see, here I have written the result of the, why I have written, why here it is written, the result of the previous block or initial digest. Now see in this figure, everyone. If I'm talking about, let's say this 512 bits, okay, then here which 512 bits is taken as an input? So previous block digest, whatever I am getting, that is taken as a input. And that's why in this figure it is written the result of the previous block, or I can say that initial digest. Let's say I'm starting from here. So now which value is mixing with the block number 1? So that means initial digest. So either if we are taking the uh, just wait. Okay, so listen here. So if I'm talking about the see, if I'm starting from here, then which value is mixes with the first block? So you can say that I'm talking about the initial value. So in this figure, I can say that, let's say, assume this is my initial digest. Okay, I'm starting from the here, and if suppose, let's say, I'm talking about some middle one, then I can say that I'm talking about what? I'm talking about the previous block, right? So let's say start with this thing. Okay, initial value. So it is a 512 bits, and all of you know that basically 512 bits means what? Total 8 words and each of 64 bits. Then you can say that 512 bits, right? Now see here. Now see this figure, everyone. So total how many? One, two, three, four, five, six, seven, eight. Total 8 words, right? So I'm taking the initial digest. Now what is my question? So now from this 512 bits, how I am getting this 512 bits, right? How I am getting this 512 bits. So now here what happened? So this 512 bits, and see another which thing is here, this word is also taken in between in this compression function, which functionality is done. So now see this figure. So what happened? So initial digest is taken, and from that what happened? The round, total round 0 to round 79, total 80 rounds are performed. So after the 80 rounds, what happened? So after, see, now again question is your mind, in this round what happened? So right now we have to assume, so say these are initial value. Now what happened in between here? Total 80 rounds are performed, and then what happened? The total 80 rounds are performed. After that you are getting some digest, right? Now whatever the digest that you are getting, after that what you have to do? The initial digest, and right now after the 80th round, whatever the digest that you are getting here, plus means what you have to perform? The addition modulo 2 raised to 64. See this initial digest, addition modulo what? Whatever the final digest that you are getting, right? So this a plus this a, so in between which operation is performed? Addition modulo 2 raised to 64. Then you get this a. So this b plus this b, addition modulo 2 raised to 64 is performed. And finally what? Whatever the digest that you are getting, that is this 512 bits. Again, I repeat everyone. Initially 512 bits means initial value. So initial value, so these are initial digest is there. Now what happened? Total rounds 0 to 17 and 80 rounds are performed. So after the 80th round, you are getting some digest. Now what happened? So whatever the initial digest is there, so let's say consider this a and e. So between what? Plus means addition modulo 2 raised to 64 is performed. So what you get? A. Similarly b, c, d. So these your what? These are digest means these are digest means this 512 bits that you are getting, right? Let's say assume here I am not taking the initial digest. So let's say, see, right now I am getting this 512 bits. Now how I am getting this 512 bits? So now in this case what happened? Now in this case what happened? What is this digest? Can anyone please reply? What is this digest? If I want to find this 512 bits, then what is this digest? Please write down in a chat window. Please unmute yourself and ask me the question.
Ma'am, here where we add that 1024 bits of block in the digest.
I'm not getting your question, Priyank.
Like in this figure, we have block 1, which is input to that compression function, right?
Yes, yes. See, later you can understand how it works. Okay. So, means I'm getting your question. What is, see? Basically, it's a word. Basically, it's a word. Yes, yes or no?
Yes, ma'am.
1024 bits means how many words are there total? What I have explained? Total 16 words and each of 1024 bits. Yes or no? So
Yes,
now
ma'am.
your question is, see, हमने यहाँ पे वो डाइजेस्ट तो किया, लेकिन वर्ड कहाँ पे गया? दैट इज योर
Yeah,
क्वेश्चन,
yes,
राइट?
ma'am.
सो
Yes, ma'am.
नेक्स्ट मैं आपको फिगर बताऊंगी, तभी आपको पता चल जाएगा.
Okay, ma'am.
Okay, okay, now your question is solved, right? So basically, see how many words we have, Priyank, in block
16.
16, right? So basically, what happened? So now see. Here what happened? These are initial digest, right? Clear, Priyank? These are initial digest. Now your
Yes, ma'am.
question is, where is this particular input? That is your question.
Yes, ma'am.
Right. So now, see here in this figure, this is the initial. Assume, see, I am finding this 512 bits. So how can I get? So this initial value is given. Okay, 512 bits. Now this given as an input, and what is this? So now see here, total these are W0. W0 means total. How many words are there? 16 words means W0 to W50. Yes or no, Priyank?
Yes, ma'am.
Right. Now again, questionnaire is their mind. What about the other words? पता
Yes,
चल
ma'am.
रहा है आपको? टोटल राउंड 0 से राउंड 18 टोटल 80 वर्ड्स है, राइट? उसमें जो पहले 16 वर्ड्स है वो तो यहाँ से मिल जाएंगे ब्लॉक नंबर 1 से,
Yes, ma'am.
राइट? अब दूसरे वर्ड कैसे फाइंड करेंगे, उसके लिए भी इक्वेशन है. सो सी, वन बाय वन यू कैन अंडरस्टैंड. नाउ क्लियर where this word is used?
Yes, ma'am.
Okay, so now here what I have done here, see, initial, there is an initial value, there is an initial digest, right? Now from this initial digest, how I am getting this 512 bits? So what I have explained here, so here you can say that the total round 0 to round 79, total 80 rounds are performed, then after that you are getting some digest. Now what you have to do, whatever the initial digest plus after the 80 round, whatever the this digest that you are getting, so a plus a modulo 2 raised to 64 that you have to perform, so you get a. So whatever the digest that you are getting, that means this 512 bits. Now clear? Now suppose again my question, I want to find this 512 bits. So now can anyone can anyone tell me what is this digest? This is the first intermediate digest, yes or no? Please reply. Got it what I am trying to say, everyone? Right? So that means, see what I'm trying to say, I want to calculate this 512 bits. So now which message digest is taken as an input? So now my first intermediate means the result of the previous block is taken. Now again the 18 rounds are taken, and finally whatever the message digest that I am getting, that is the 512 bits, right? Now the question is, what is about this word? So here you can see that this word W0, and all of you know that here that in block 1024 bits means the total 16 words and each of 64 bits. So that means here you can say that this W0 means out of this 16 word W0, then W1, W2, W0 is taken in a round 0, W1 is taken in a round 1, W2 is taken in a round 2, in that way up to 15 it is taken. And then again questionnaire your mind, what about this round 79 and all that? So again, how to find it later, I will explain you how you can do it. Up to this clear, everyone? Anyone have a doubt?
Hello, ma'am.
हाँ बोलो.
That result of that final addition should be input from input of that next iteration.
Yes, see here in this case, Priyank, what happened, see here in this case what I have done here, lecture માં જો પછી કરું. See here what happened. See, Priyank, what I'm trying to say, suppose let's say this 512 bits, let's say initially I'm taking from here. So this initial value is given. Yes, mill right, that is this one. Again, what happened? So again, whatever the answer, whatever this answer is taken, so now there is given as an input to this. पता चल रहा है?
Yes, ma'am.
नेक्स्ट के
Yes,
लिए अब
ma'am.
इनपुट ये जो अभी जो आंसर मिला आपको, ये वाला इनिशियल हो जाएगा. Now
Okay.
clear? Right? This becomes a input. Again, total 80 rounds are done, and finally you are getting 512 bits. The same process is repeated. And so many times, how many? Up to block n it is done, and whatever the after the block n, whatever the final answer you are getting, that is what? That is your final answer. Clear? Is it clear?
Yes, ma'am.
Okay, fine. Okay, now fine. Now what happened? See here. Okay. Now again question arise your mind everyone. So from this initial digest what happened? So if I am applying the round number 0, so now from this initial digest if I am applying the round number 0, then how I am achieving this A2H? After the round 0 how I am getting the result, after the round 1 how I am getting, got it what I'm trying to say? This is my initial digest, right? When round 0 is applied, so at that time which thing I am giving as an input, all of you know that w0, that is the word, and some constant is there. Later I will explain you what is this constant, right? So now see, when you observe this figure, so all of you know that this is the initial value, here the word is taken, it also mixes with this block, and then finally, so let's see, initially the round 0 is applied, so some value that I am getting, right? So now see here. So this thing I want to explain you. This is the initial digest. Now when I'm applying the round 0, then how I'm achieving this A to H. This is only for round 0 I will explain, let's say. So now see how it works. So all of you know that in input, which thing is given? W0, K0, and the initial vector. This thing is given as an input to round 0, right? So finally, what you get after the round 0, this thing is given as an input, and after the round 0, what I'm getting? I'm getting this 512 bits, right? So now the question era is that is in this particular input, how I am getting the output. See, I'm talking about this round 0, everyone. Okay, how I am achieving this A to H. So now see what happened. So the A is copied to B is copied to C is copied to D, E is copied to F is copied to G, and G is copied to H. This thing is done. So this is my initial digest. Now when round 0 is applied, okay, so now I am getting this result. Okay, so now in this case, how I am getting this result? So these are predefined. A is copied to B is copied to C is copied to D, E is copied to F is copied to G, and G is copied to H. Right now the question is how I am getting this value. Which value? So A and E. How I am getting this? Let's say A is denoted by X and E is denoted by Y. So in the above figure, the six buffer are the exact copy of the one of the buffer in the previous round. Now again the question arises your mind, that is how we are achieving this X and Y, right? So for that, what you have to do, understand, see each and every topic are related everyone, right? So first you have to understand the previous one, so go through the whole theory. Now how we are achieving this X and Y. So now see this figure again, you have to remember this figure. So now see in this figure, see now I will explain you each and every concept. That is the one majority function is there. In that ABC, these are the parameter, rotate, and that this is a sign that means the addition modulo 2 raised to 64 is performed. Then this is a mixer 1, this is a mixture 2, where the conditional operator is done, and then finally what happened, whatever the value that you are getting after the mixer 1, from mixer the 2, right? And then again here plus means, see actually what happened. So first majority of ABC, this thing is performed, rotate A is performed. Now later I will explain you what is majority and rotate everything. Then again in between the addition modulo 2 raised to 64 is performed. So what you are getting, here's some value that you are getting, right? Again here the conditional EFG is performed, rotate E, this thing is, see right now you have to assume this type of some functionality is there. Okay, now this thing is added, this is a word ki, and then finally some mixture that you are getting, right? And that is that you are getting y, and here this mixture 1 mixture 2 result, again you are performing the addition modulo 2 raised to 64, and finally you are getting x. So after so many steps you are getting this x and y value, right? So now how it works, that I want to explain you. Now see here. So first you have to understand, see, first you have to understand what is, see, simply basic function I will explain you, what is majority, what is rotate, conditional, what is rotate e. Only that thing that I will explain you, okay? And otherwise you have to if you want to solve it yourself, okay? So how to find this majority ABC? So what is the equation for this? So majority x, well, let's say instead of ABC I'm taking xyz. So the equation is x and y xor y and z xor x and z. This type of equation you have to remember. So this type of question may be asked in exam. So now let's say x is taken as a c1, y is taken as a a, and z is taken as a e. So first you have to write down the binary of it, right? So now how I'm achieving this? So x is 0 1 1 1 0, and once you know that in end 1 1 then 1, so you get 0 0 1 0, right? Now similarly here y and z, okay, y and z. So here you can what you get 1 0 1 0 xor x and z. So what you are getting here 0 1 1 0. So this thing that you are getting. Now after that what you have to do, you have to perform the xor, right? You have to perform the XOR. So first perform the XOR between these two. And all of you know that this is the truth table for XOR. All of you know that there is no need to explain. So first perform the XOR between these two. Whatever the result getting, again XOR with what? The first one. Okay. And finally what you get? You get the E value. Right. So that means the majority of 7AE, that is E. So if my input is 7AE, then after that the what I am getting for majority, I am getting E value, right? So here I am getting what? E value, right? That you have to keep in mind. Now how to perform, what is rotate? So I'm not taking the same data every time, right? You can take any example and you can find it, okay? So just I want to explain you the basic concept, what is majority, what is rotate, what is conditional, right? That all concept I will teach you. So up to this clear everyone? Is it clear to you all what I'm trying to explain? Yes or no? Clear with this idea, round structure, compression? Yes or no, everyone? Okay, fine. Now the next that is rotate. Okay, so for rotate, this is the equation. See here, rotate of A. The rotate of A, that is rotate ROT R, and see here I. What is represent? See here I have written the right rotation of argument X, right rotation of argument X by how many bits? I bits. So here the equation of rotate A, that is rotate R28A. What is the meaning of it? The meaning of this rotate A, that means the right rotation of argument A by how many? 28 bits XOR right rotation of A by how many? 34 bits. See here there are so many bits are there, right? So I will not teach you in that way because it's a very complex, it becomes very complex. That's why I will take only 3 or 4 bits, okay? And in that way I will explain you. But this is the general syntax. So when you write rotate A, the meaning of it is ROTR means the right rotation of argument A by 28 bits, XOR right rotation of argument A by 34 bits, XOR right rotation of argument A by 29 bits. This is rotate A. Similarly, the rotate E, instead of A, I am writing E. Okay, so this is the syntax for rotate A. Now, how the rotate right, that is circular, how this is performed. So by using this concept, just there's a so you can understand. That's why I have written here. Let's say suppose my beat is 1011. So how the rotate right is performed? So now see here. So rotate right is this 1 0 1, and this bit that is your, it is in the first position. Again what happened? See this 1 1 0, and this becomes this at the first position. So again what happened? 1 1 1 and 0 in at the beginning position, right? Then again see, let's say 0 1 1, and then again 1 is there for first position. So these all about rotate right operation. So is it clear everyone? So there are so many bits are there, so I will not explain you for 28 bits. So this is the basic concept that just you have to understand in this theory. Janil, I'm not getting. See, is I value in rotate is random? What you are trying to say? No, these values are fixed in this equation. See, these are the equation in SHA 512. See, these are hash function model, and in that, see, this model is fixed, right? Basically, what we are doing here. So here in this case, what I'm trying to explain, Janil, that is, these are initial digest is given to you, right? What I'm trying to explain, the initial digest is, see in this our figure, the initial digest is given to you. Now how I am getting the 512 bits? So what I'm trying to explain, the initial digest is given to you, total round 0 to round 79 are performed. But see, when after the round 0, what result that I am getting? So now see here, so there's an initial digest. Now once a round 0 is performed, I am getting some digest. Now how I am achieving this value? So for that, what I'm trying to say, everyone, so these my initial digest. Now after the round 0, how I'm getting this value? So this all values are what? It's an exact copy. But now my question is, how I am getting this X and Y? So for that, this model that you have to implement. Okay, so by using this model, if you are following this model, then by performing this, you are getting the value of X and Y. So for that, I will explain you what is this majority, what is this rotate, what is this conditional, each and everything. Now it's fine, everyone. Now the concept is clear to you, right? Now, so I think all are clear for rotate. Okay. And see, these bits are fixed. But see, in exam, I will not explain you in this way. Because see, these are the 28 bits, right? So I will not ask you the question like this. Okay. Now, what about this conditional? Okay. So, see here. And all of you know that in conditional, the three parameters are there, right? So, what is the equation for conditional x, y, z? So, the equation is fixed x and y, x or not x and z. Okay. So, this is the formula for conditional x, y, z. Let's say the x is 9, y is a, and z is f. Right. This is the binary of it, and not x. That is what not x means 0, 1, 1, 0. Right. All of you know that. Now, what is x and y? So, what I am getting 1, 0, 0, 0. Not x and z, then what I'm getting not x and a bit in this is z. So between them, so 1 1. So here I'm getting 0 1 1 0. Okay, and then I am performing this operation. So when I'm performing this operation, then what I am getting 1 1 0 1 1 1 0. So here, what I'm getting e, that is in hexadecimal, that I am getting the value. So this is the conditional operation, right? Up to this clear, everyone? Is it clear to you all? So this the thing that I've explained, that is, this is my initial digest after the round 0. How I am getting this digest? So through this example that I have explained, this is the initial digest after applying the round 0. How I am getting this digest? For that, this all value that I am getting, but how I am getting this x and y value? So for that, this structure is there. In that I have explained how to find the majority, how what is rotative, and what is conditional, right? So after that, you can say you are getting this value, right? So now in this figure, you can say that after the round 0, I am getting this value. Now I think the Priyank has asked me a question, that is, where this is where these are particular words are used, right? So now see, Priyank, here in this case, these are initial value, and see, in block 1 you can say that 1024 bits is the total. How many? Total 16 words, and each of 64 bits. So now see here, when this round 0 to round 79, these are performed. So in that case, when you observe this figure here, the words are used. right? So now in this case, total in the block 1, how many words are there? Block 1 total 16 words are there. So now out of that, what happened here? When round here in this case, what happened? There is an initial value, and when round 0 to round 79 are performed, and after that, at after the 80th round, you are getting this 512 bits. All of you know that, right? So in that case, what happened in round 0 to round 79? So all of you know that in this particular block, total 16 words are there. So now out of the 16 word in round 0, W0 word is used. Round 1, W1 word is used. Round 2, W2 words is used. Total for how many? Total we have 0 to 50. Means total 16 words are there. Now again question arises your mind कि after the 16 word, in the round 17, which word I am using? Right? In the round 18, which word I am using? Right? So that question is there in your mind. So that's why what happened? The now here in this case, the concept that is the word expansion. So what you have to do? You have only 16 words, right? 16 word. So each block contains the 16 word of 64 bits, right? But total 18 rounds are there. So now what we require? We required a word expansion, right? Because after the round 7, at in round 17, which word is used? So for that you have to use one formula, and based on that you have to find that word. Up to this clear, everyone? How exactly the SHA 512 is work, right? So I think the last 2 minutes is lesser. Just I will show you this figure. I'm not explaining you in detail, but in next class, starting with this word expansion. Again, just quickly in next class, I will go give you quickly give you overview and directly start with this word expansion in next class. Okay, so now see here, all of you know that a block, a particular block is made of 1024 bits or 64 bits. But see how many words we require, that already that I told you. We need 80 words in a processing phase, right? So total, so the 16 word block needs to be expanded to how many? To 80 words from the W0 to W79. Right. So we have this W0 to W5, right? That already that I told you. So what is the word expansion in SHA 512? So see, these are the this is a block of 16 word, 1024 bits. All of you know that W0 to write this many words. But after that, if you want to find a, let's say, W17, then what you have to do? So this equation that you have to use, and based on that you are getting the word at W17. But that I will explain you in next class. Okay, how to perform the word expansion. So is it fine up to this, everyone? Clear? Right? So in next class, I will explain you the word expansion. Okay, thank you everyone.